a 1, a 2, a 1, 2, 3. To find the components of a force, imagine you're doing an obstacle course, but you're not allowed to travel diagonally, only horizontally and vertically. I like to think of finding the components of a force as being the exact opposite of finding the resultant force. Whereas for a resultant force, you add two forces together to find the overall force, here we split an overall force into the two parts that would make it. We call those two parts the components. So what we're going to say is this 10 Newton force could be achieved by having a horizontal force, a force to the right, and a vertical force, in this case a force up. Imagine you're going on a journey. Imagine you wanted to travel 10 meters from here to here. You could instead go this distance to the right, followed by this distance up, and you would achieve the same thing. Forces work in exactly the same way. Now, to find the size of this horizontal force and the size of this vertical force, we're going to draw a scale drawing. So for this example, I can use a scale of 1 centimeter equals 1 Newton. So I'm going to draw a line 10 centimeters long to represent the 10 Newton force at an angle of 37 degrees to the horizontal. I'm going to use these horizontal lines on my page as my horizontal. I'm going to use this line over here. That's my horizontal. So I firstly need to measure an angle of 37 degrees to that line. So using a protractor, I'm going to measure an angle of 37 degrees. And then I'm going to draw a 10 centimeter line at that angle of 37 degrees to the horizontal. You would do this with a sharp pencil and a ruler to ensure that your diagram is as accurate as possible, although exam boards on their mark schemes will give you a certain range of allowed answers. So there we go. Now I have a 10 centimeter line, and this angle down here is 37 degrees. Now finding the components is very straightforward. All we need to do is say, to get from the beginning of this force arrow to the end of this force arrow, what journey do I need to go on if I can only move horizontally and vertically? So the journey you would need to go on is a certain journey to the right, followed by a certain journey up. Notice I've drawn this line too long, but it doesn't matter because I can just ignore this part. I now have my two components. This here is the horizontal component of the force, and this here is the vertical component of the force. I now measure the length of those two arrows. This is 8 centimeters. This is 6 centimeters. I therefore have my two components. Converting it back to newtons using my scale of 1 centimeter equals 1 newtons, I get my horizontal component, which is this one down here, as being 8 newtons, which is this one, and my vertical component, which is this one, is 6 newtons. So just to summarize what I've done, I've said that a force at any angle, a force in any direction can be split into a horizontal component and a vertical component. In this case, my force was kind of to the right and up, so my two components were a force to the right and a force up. I'm sure you can imagine that there would be other forces with other directions. If you had, for example, a force which was in this direction, that would be made of a force up and a force to the left. You could also do it in the other order. You could go left first and then up. It doesn't matter. You could also imagine a force which travels to the right and down. The two components would therefore be this arrow to the right and this arrow down. You could also imagine a force to the left and down, and that would be made of a force arrow down and a force arrow to the left. The idea is that you can use a scale drawing to find the sizes of these components. We call the horizontal one the horizontal component and the vertical one the vertical component. A 1, a 2, a 1, 2, 3. To find the components of a force, imagine you're doing an obstacle course, but you're not allowed to travel diagonally, only horizontally and vertically. If you have any questions or comments, please comment below. Please like the video if you liked it. And also subscribe, because then you'll see any other videos that I post about A-level physics and about GCSE physics. Thank you.